Problem 2. So suppose you know that f of x is this function, f prime of x is this function, and f double prime of x is this function. We want to find all the things, the intercepts, the asymptotes, the first derivative stuff, the second derivative stuff, and graph it. We also want to find intervals where it's increasing, decreasing, etc. But we're going to find that when we find all the things. So let me change that a little bit. It's a little bit better for you. Let's find the intercept. So y-intercept, we're going to set x equal to 0. We're going to get f of 0 equal to negative 3 times 1 over 2 squared, which is negative 3/4. X-intercepts at the top equal to 0. We get x minus 3. Wow, my writing's really good. X minus 3 times 2x plus 1 equal to 0. We end up getting x equal to 3 and x equal to negative 1/2. Vertical asymptotes going to happen at x equal to negative 2. Horizontal asymptote is going to happen when, well, if we look at the degree of the top and the bottom. Oh, and I know that when makes you show the horizontal asymptote, I can show that there isn't one, right? So for the horizontal asymptote, right, we'd have the limit as x goes to infinity of, if you multiply out the top, it's x squared minus 6x plus x, so minus 5x minus 3 all over x squared plus 4x plus 4. Since the degrees on top and bottom are the same, you're going to get the quotient of the leading coefficients, which would equal 1 over 1. And if you have to show more work, the work is to divide everything by x squared, which is the highest power of x in the denominator. And then you get 1 minus something that goes to 0, something that goes to 0 over 1 plus something that goes to 0, something that goes to 0. Okay, first derivative stuff, we're going to set that equal to 0. And we're going to end up getting that x is equal to positive 4 over 13. Right, if you set the top equal to 0, you get 13x minus 4 equals 0, and then 13x equals 4, x equals 4/13. We also need to include where x is equal to negative 2, because that's going to make the first derivative undefined. It's not a real critical value because it's not in the domain of the function, but it does need to go on the number line. So drawing my first derivative number line here, I have positive 4/13 and negative 2. Pick something bigger than that, like 10. 13 times 10 is big. Minus 4 is still positive. Denominator 10 plus 2 cubed is positive. Pick something between negative 2 and 4/13, like 0. 0 minus 4 is negative. 0 plus 2 cubed is positive. Whole thing's negative. And then pick something less than negative 2, like negative 3. 13 times negative 3 is really negative. Minus 4 is still negative. Negative 3 plus 2 is negative. Negative number cubed is still negative. So negative over negative is positive. So our function is increasing, decreasing, increasing. If you had to write the intervals, it'd be increasing negative infinity to negative 2, union 4/13 to infinity. It'd be decreasing on the interval from negative 2 to 4/13. And then we would say that we have a relative minimum at x equal to 4/13. We do not have a relative maximum at negative 2 because we have a vertical asymptote at negative 2. And hopefully if you had to find the y value at 4/13, it's kind of gross. Plugging in f of 4/13, yeesh, okay, 4/13 minus 3 is 4/13 minus 39/13, which is negative 35/13. That's terrible. 4/13 times 2 is 8/13 plus 13/13 is 21/13. Yeah, that's dumb. And then 4/13 plus 2 is 4/13 plus 26/13, which is 30/13 squared. The only nice thing about this is that all the 13s cancel, right? Dividing by 13s, divided by 13s, and you flip a multiply, you multiply by 13 times 13 over 30 times 30. This ends up being negative 35 times 21 over 30 squared, which is still dumb, but you could say that's your number. I don't want to do more with that, but it's going to be, I don't know, it's negative 35 times 20, okay, fine. Negative 35 times 20 is negative 700, times another 1 is negative 735. So it's negative 735 over 900. That seems stupid. All right, and then finally the second derivative stuff. So our second derivative is equal to 0 when x is 19/13. And then we also still have to include x equal to -2. So here's our second derivative number line. So we have, again, -2 and then 19/13. Again, to get the 19/13, I'm just setting the top equal to 0 and then 13x equals positive 19 and then x equals 19/13. Pick a number larger than that, like 10. 130 minus 19 is positive, times the -2 is negative, divided by, the bottom will always be positive, so negative over positive is negative. Between -2 and 19/13, let's pick 0. 0 minus 19 is negative, times -2 is positive, bottom's always positive. And then finally over here, pick something like -5. The bottom is still always positive, and then -2 times, let's see, -65 minus 19 is, again, actually pick -10, that's easier. -130 minus 19 is negative, times -2 is positive, and the bottom's always positive, so it's positive here. So it's concave up, concave up, concave down. So I'd say it's concave up on the interval from -infinity to -2 union -2 to 19/13. We're not including the -2 because the function's undefined there, so it can't be in your interval of increase or concave up. Concave down from 19/13 to infinity, and then we do have an inflection point, and I'm going to kind of fake it here. We have an inflection point at x equal to 19/13, and the y value is f of 19/13. Usually they're not going to ask you to find such a terrible y value, but I will find it at the end if you guys really want me to, which means I'll do it because I'm just recording a video. You can't see if you want me to or not. So let's graph the thing. We had, let's see, we had y-intercept at -3/4, x-intercept at +3 and -1/2, horizontal asymptote at +1, vertical asymptote at, was it +2 or -2? It was -2, okay. And then we had a relative minimum at -2, -735. So that, okay, so this number, -735 or 900, is not quite as negative as -1. So it's probably like right here-ish. Here's my +4/13 and my value. I know it's got to be lower than this y-intercept, and then it's got to get bigger afterwards. So we're going to do something like this. And then my inflection point is at 19/13, whatever the y value is. So I just know, like, so 19/13 is kind of 1.5-ish, right? It's 13/13 plus 6/13, so it's between 1 and 2. And right here, we're going to change from being concave up to concave down. And we still have to go through that point, and we still have to, like, do this. On the other side, so again, now I'm going to look back at my first derivative stuff. So my first derivative stuff says we're increasing before we get to -2, decreasing from -2 to 4/13, and then increasing afterwards. So we are increasing until we get to -2. We are decreasing after -2. And then until we get to, right, there's my 4/13, whatever the terrible y value is. And then from after here we are increasing. And then right there's my inflection point at 9/13, f of 9/13. So it's concave up, and then right here we change from being concave up to being very, very slightly concave down. And if we really care, we can say that f of 9/13, if we plug that into the original function, it's not pretty. It's 9/13 minus 3 is 39/13, and then it's going to be 2 times 9/13 plus 1. So 2 times 9 is 18/13 plus 1 is 13/13 divided by 9/13 plus 2 squared. So that's going to be 9/13 plus 26/13 squared. Again, this is terrible. You could simplify this a little bit if you wanted to. That's -30 over 13 times 31 over 13. And then 9 plus 26 is 35 over 13 squared. The 13's cancel. So you end up with -30 times 31 is, let's see, 900 plus another 30 is 930. divided by 35 squared is, what is 35 squared? I don't know. It's a number. I guess I could find it out. I don't really want to find it out, but where'd my calculator go? Fine. 35 squared is 1225. Great. So there's that one there. All right. That's problem 2.